Yes, sir.
Is it possible to have a PVC and an idioventricular rhythm?
Yes, it is. But now here's the thing. Now remember, with the idioventricular, you teach me. Now, tell me, what does an idioventricular rhythm, which we're recording, by the way, what does an idioventricular rhythm look like? What is its two important characteristics?
Bizarre looking QRS,
One,
and also a ventricular pace. Well, the pacemaker is coming from the ventricles.
which means what is the second
No,
characteristic of that based on what you just said?
no P waves.
Well, that's, yeah, that, you're going to have that bizarre looking one. But what about the rate?
Can be bradycardia.
Right. And it's not only going to be bradycardia, but almost always it's going to be really bradycardia, 20 to 40 most of the time in there. So keep in mind that if you see a PVC, which you can because PVCs originate where? In the ventricles. Why is your patient in an idioventricular rhythm? The heart is in the process of dying, so it literally can do anything. But your PVC would look different than your underlying idioventricular rhythm. And almost always, if you get a PVC with an idioventricular rhythm, the QRS will go the opposite direction of the QRS in the idioventricular. So it will look almost inverted. So it'll look entirely different. Does that help? All right, that's a good question. You guys have been such a good class. You really, really have. I have just thoroughly enjoyed this 303 class. Any other questions that you've got before we jump into the review? All right, so here we go. So here's the thing I'm going to do today. Just going to take the sign-in sheet. We're going to go alphabetical. So Sydney, you know what that means. A, Arnold. Hold on. What I'd like for you to do, take your time and just give me the name of the rhythm that's on here. And again, after today, I will post these on Blackboard so you can use them for your own review. So the rhythm is regular. Rate is that of the underlying sinus rhythm. Both atrial and ventricular rate will be the same. P wave sinus, 1 P wave to each QRS complex. PR interval is consistently prolonged, greater than 0.20 seconds, and your QRS complex is normal. What is that rhythm that we're describing? Just Sydney. Okay, so it's not a second degree. Caden, boring.
Is it NSR with a first degree heart failure?
All right. So now in this situation, when I give it to you like this, again, I'm not identifying the underlying rhythm, but yeah, you're exactly right. It is a first degree heart block. So with this information, we don't have any information about the underlying rhythm. So when you tell me it's a sinus rhythm or a first degree heart block, it's kind of like, okay, that's great. That'll work. All right. But what we're actually simply describing there is just the first degree heart block. All right. Excellent.
When we have like an EKG, you want us to like describe it.
Absolutely. With a first degree heart block that's with an EKG, you always have to tell me the underlying rhythm. And remember, the underlying rhythm will almost always, not always, but almost always either be a normal sinus rhythm or a sinus bradycardia. Okay. I've never seen a first degree block in a sinus tachycardia. It's just too fast. Okay. But with this one, you can tell me first degree heart block and you're 100% okay. All right. Naomi, name that tune. That is torsades. The other name for this is what? Not VTAC. We can call it multifocal ventricular tachycardia. I'm okay with that. What's the other one? I heard somebody say something over here. Okay.
Did you say it was like polymorphic tachycardia?
Yeah, polymorphic. As we look at this right here, going through here, let me get my little laser pointer. Actually, let me do something a little different here. I mean, you can watch that it crescendos and then it drops. And it comes back up again and it drops. And it comes back up again. And you have that kind of that undulating format that looks really, really similar whether you're up on the top or down on the bottom of all the QRS complexes in here. Okay. If you identify this as VTAC, I will count it wrong because it is a specialized type of VTAC that we treat differently than we would just your run-of-the-mill, ordinary, everyday VTAC. All right? Questions? Yes, sir.
Could it be called polymorphic VTAC as well?
Absolutely. That's what James had said here a minute ago is you can call it polymorphic VTAC and you're good. You're perfectly good. All right, Catherine. What we got there? Why is it AFib?
It's firstly regular and there's no distinct P.
Okay. I'm taking the rest of the day off and you're going to teach. That's exactly right. Okay. When you see a rhythm that you cannot identify any P waves, upright or inverse, the very next thing you need to do is to look, is this rhythm regular? And if it is very irregular, that's a pretty good indication that it is indeed going to be a fib. All right? All right, Dylan, here we go. Rhythm is regular. Rate is 60 to 100 beats a minute. P waves are inverted in lead 2 and occur immediately before the QRS complex. It can happen after the QRS complex, or it can be completely hidden within the QRS complex. The PR interval is short, usually 0.1 seconds or less, and the QRS complex is normal. What is that rhythm? Is Dylan here? Somebody signed in. Caden, Elliot, let's go to you. What's that?
He's right here.
Oh, you were thinking about. I'm sorry. Take your time. Tell me what you think it is. Is it junction? It's not junctional. Caden, what do you think it is?
Second degree type 2.
Not second degree type 2. Kelsey?
I'm not sure.
That's okay. All right. I don't know. It's a good answer when we're practicing. Jaden.
MNT.
Mm-mm. Braden.
Accelerated junctional.
Why is it accelerated junctional?
Because the rate for junctional rhythms is usually 40 to 60, and then the P waves are, I guess this rate's faster junctional, and the P waves are inverted.
Yeah. So we have a rhythm that is regular, so it tells us it's coming from the same pacing site. Second thing is it is 60 to 100. That doesn't tell us a whole lot yet, but now when we look at our P waves, it says they're either upside down or they're after the QRS or they're embedded in the QRS, which tells us that it's coming from somewhere within the junctional area. So if this rate were 40 to 60, then it would indeed have been a junctional rhythm. But because it is faster, we call it accelerated junctional, or you can call it what else? Junctional tachycardia.
I thought you would never see P waves in accelerated functional rhythm.
Yeah. So I mean, accelerating is just anything that's going to be faster than 60. So, yeah, you will see P waves again in the junctional rhythm unless they're not there. And then again, how would we? Let me ask you a question, and everybody else. How would we determine then if we're not seeing P waves that this is a junctional rhythm and not a fib?
If it's regular or not, grossly rare.
That's absolutely. So if we don't see them and it's regular, then it's going to be a junctional rhythm. Okay. Any other questions on this one? All right. Way to stay with it. And again, I put something up here and you don't know. Don't worry about it. This is the place where we're going to learn. All right. James.
Is that third degree? Why?
Not third degree. Brennan,
That would be a second degree type 2.
you are correct. Okay. Now here's the thing to look at. All right. Here's first of all, tell me why, and anybody can do this. Tell me why this cannot be third degree.
Because the PR intervals on the P waves are connected are all the same.
It is possible in a third degree, although it's highly unlikely, that we could indeed see PR intervals that would be the same and it still be a second degree or a third degree block. So, but yeah, in this situation, the PR intervals are all the same. What else do we see in this rhythm that would make it a second degree type 2? Or let me back up. What do we see in this that eliminates it from being a third degree? James.
I'm just not saying it. It's more like constant.
What is that? What do you mean by constant?
Well, when I'm looking at the P waves and the T waves, with the rhythms, it looks to be constant with each other, even despite the drop QRSs.
Okay. Now remember what's the pathophysiology? What is happening in third degree block? What's occurring?
The atria aren't communicating with ventricles.
Yeah. So ultimately, what does that mean? Atria are firing at a regular pace. Ventricles are firing at a regular pace. So we could potentially make the argument that we do see kind of some regularity here, although it does begin to get to space out a little bit. But look at our QRS complexes, okay? We got this really big long pause here before it picks back up. The other thing, Travis, I'll come right back to you. If the ventricles are firing, what else should we notice about the QRS complexes?
The QRS would be wider.
Bingo. These are too narrow. These are too narrow for it to be third degree block. Okay. So this is second degree type 2. Again, if you'll look at the PR interval, it is constant. It is constant. And then boom, we have a drop beat. And boom, we have a second drop beat. And then it picks right back up with the PR interval being constant, constant, and constant. Everybody got that? Any questions on that one?
If that repeated, what would you call that rate?
The rate?
The drop beat rate.
So there's no ratio that we would have in a block. But if it repeats on a regular basis, we could potentially call it a 2-to-1 block. Yep.
If we saw this on the exam, you would want us to identify the underlying rhythm with this.
Mm. Second degree type 2 is a standalone rhythm. Remember, in the AV blocks, the only block that has an underlying rhythm is first degree block. That's the only one. All the others, they're on their own. All right? Let's see here. Matt, tough one here, man. Stay with it.
VFib.
That is VFib. Tell me what's going on in the heart in VFib.
The ventricles are just kind of like they're not fully like depolarizing. They're just kind of like quivering.
Yeah. Good. So think of a bowl of Jell-O. You set it on the table and you bump it. You see it kind of do this right here. That's the exact same thing that occurs with VFib. The heart just quivers. There's no cardiac output. There is no pulse. Your patient is in cardiac arrest. Bonus point here. What is the primary treatment for ventricular fibrillation? Defibrillation. Excellent. We're going to shock. Good job. Good job. All right, Carson. You got a rhythm that's regular, beat 40 to 60 beats a minute. P wave's inverted in lead 2, and it happened before the QRS, after the QRS, was hidden the QRS. PR interval is short, and the QRS is normal. This is a junctional rhythm. Now, let me ask y'all a question. In junctional rhythms, why is the PR interval shorter?
It's closer to the AV junction.
Yeah. And actually, so let me clarify that a little bit. So, yeah, you're exactly right. So this impulse is actually arising out of the AV junction. Therefore, it's closer to the ventricles. So the AV depolarizes, and then it depolarizes the ventricles. Another question, why, if we see P waves, are they inverted?
So the impulse has to come up towards the positive.
Towards the positive or the negative?
Positive, right?
So the positive one is down here. So it's going up and away from the positive lead. Okay? All right. Emily, what's that rhythm? What do you think? I'm sorry, I still didn't hear you.
It looks funky.
It looks funky. Okay, I'd agree with you. That's not the right answer. Let's continue on. Travis, what is this rhythm?
This is sinus bradycardia with 2 PJCs.
Okay, good, very good. Now I've got it listed as normal sinus rhythm, but it is indeed sinus bradycardia. Now, if you wanted some extra points on this, if you were to point out that the PACs are where, Travis?
I thought they were PJCs.
I'm sorry, PJCs. Yes, it is inverted. So we got a biphasic P wave there. So if you wanted the extra points with the PJCs, what else could you tell me?
That they're second and fourth impulse.
So the second and fourth impulse, and if you wanted to, you could tell me that they are unifocal. What does unifocal mean?
They look the same.
They look the same. They're coming from the same impulse. Okay, so that would get you some extra credit. All right, excellent. Josie, what's that rhythm? I love looking at the expressions of y'all while you're thinking of this. I'm in pain.
Because it's like going through fibrillation, but I don't know. Because it has an inverted P wave too.
Mm-hmm. But now again, is it regular or not?
What was the question?
from your rhythm. Is it regular or not?
Yeah.
Okay. So that eliminates what? You said you saw like fibrillation waves, and you see.
Eliminates that, yeah.
So what is that? What rhythm does that eliminate though? Somebody help her out. What does that eliminate? A fib. A fib. Okay. So what would you call this one, Josie? If you see it on the exam. Okay. Not sinus bradycardia. Sydney, we'll come back up to you. It is a junctional rhythm. So you can either cause, because it is slow enough and it's close enough to the border there that you can call it a junctional rhythm or a junctional bradycardia, and I'd be okay with either one of them. Okay.
Junctional rhythm, the ones like between 20 and 40.
That's ventricular.
Okay.
Yeah.
Why would it be bradycardia? Because it's pacing at the normal rate.
Because if you look at in particular this little guy right here, it is so close to just barely being in on. I can't draw a straight line. Barely being in on that 6 second. That if you were to call it junctional bradycardia, the key here is can you identify it as junctional? If you were to call it junctional bradycardia, I'd be okay with that. But because it is within that 6 seconds, I would also give you credit if you called it junctional rhythm. All right? Yep.
Quick question. Is there any, so if you see inverted T waves, is there any option except something junctional? Like, are there any rhythms that have inverted T waves other than junctionals?
No.
Other than
That makes it a lot easier. Okay.
Say it again. Well, again, okay, let me clarify that because you said something really good there, okay? It is possible to see a mixture of regular P waves and inverted P waves, and it could be, what did you just say? Yeah, it could be MAT or WAP. So literally you could get some impulses that are coming from the atria, some that are coming from down in the AV node, and again, it could be wandering atrial pacemaker, multifocal atrial tachycardia. Very good point. If all you see are inverted P waves or disappeared P waves and it's regular, or P waves after the QRS and it is regular, then it's got to be some type of a junctional rhythm. Junctional bradycardia, junctional rhythm, or accelerated junctional rhythm, also known as junctional tach. Okay? Good questions, guys. Anybody else? All right. I'm just going to throw these out for anybody now for the remainder of our time. What's that rhythm? James?
Is it pulseless electrical activity?
Yeah, PEA. Okay. Little expert hint. Anytime you see no pulse up here, that tells you that whatever we're seeing down in here is electrical only. So this is pulseless electrical activity. Now, I'm going to tell you right now that I'm going to throw you a curveball on your final exam. I am going to put up no pulse on some rhythms that may be asystole, some rhythms that may be V-fib, and some rhythms that are V-tach, including torsades. If you see asystole, V-tach, torsades, or V-fib, do not call it PEA. Okay? Do not call it PEA. True, there's some electrical activity that's occurring in all those with the exception of asystole, but you got to call it by the right name. In asystole, you're not going to have a pulse. In V-fib, you're not going to have a pulse. In V-tach, you can have a pulse or you can not have a pulse. Same way with torsades. You can have a pulse or not a pulse. So this is now we're kind of making that transition now from intro to cardiology into advanced cardiology. So just kind of remember that. Yes.
Does that rhythm have a name? That's what I'm wondering. Aside from PEA.
Nope. Anytime you see this one right here, because it's not asystole, VTAC, or VFib, any other rhythm that you would see like this, or torsades, you would just simply call it PEA. Don't call it, there's no underlying rhythm. You just look at it and go, that's PEA. Sydney.
So on the exam, if it says PA, but it's actually VTAC, you want us to call it VTAC?
Yep. Because that's what it is. Because again, we don't call, and you guys are rising to this level, okay? Remember, I bagged on you a while ago, so you've done this to yourselves, all right? We don't call VTAC PEA, although there's electrical activity that's going through, but it's a different type of rhythm. So again, so for example,
So besides VTAC and torsades, what other ones?
so if I'll come right to you. On your EKG or on your final exam, you will have a rhythm that looks like this, and I'll simply put up the top, there is no pulse. I want you to identify that as VFib. Here's why. I don't want you to simply begin to look for that there's no pulse and go, oh, well, he's told us the answer because there's no pulse. It's got to be PEA. PEA is not the only rhythm that does not have a pulse, okay? So the 4 that you need to be aware of are asystole, VFib, ding, 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 VTAC, and torsades, okay? So you will see a rhythm like this that'll say there is no pulse. Later on, you'll see a rhythm like this that won't say there is no pulse. Both of them are VFib. Yes?
So we couldn't say VFib with PEA, it would just be
No, because it's not PEA. It's a different organization. Okay? Anybody else? Don't freak out. You guys will be okay with it, I promise. I promise. Okay, let's get here. All right. Throwing out to the group. Grossly irregular unless the ventricular rate is very rapid, in which case the rhythm becomes more regular. The atrial rate is 400 beats a minute. You can't see it on your EKG. Ventricular rate varies with the number of impulses that's conducted through the AV node to the ventricles. P waves, irregular wave deflections called fibrillatory waves or F waves. Your PR interval is not measurable, and your QRS is normal. Name that rhythm.
atrial flutter.
Not atrial flutter. Atrial fibrillation. Again, potential bonus question. What is the big danger with atrial fibrillation? As a result of blood clots. So if I put that up there as a potential bonus question, I want you to tell me blood clots, because it's not just, yes, indeed, it can be a stroke risk, but it can also be a heart attack, or it can be a pulmonary embolism. So if I give that to you as a bonus question, the big thing is you tell me that a clot can develop. Okay? What's that? If you wanted bonus points, what could you tell me about that? 4-to-1 conduction. Okay, 4-to-1. Or you could put in there, if it is, you got to be right, you can say variable conduction. So if that first R to R interval, you may have 3 flutter waves, and the next one you got 2, and the next one you got 6. We'll make it slightly irregular. How do we tell the difference between this and AFib if this is irregular? Sawtooth. Sawtooth. All right. Good. What is that? Let me blow this up for you a little bit. I'll try to have ones that are larger so that you can see.
Junctional tachycardia.
Junctional tachycardia. Okay. Why is it tachycardia? It's faster than 60 beats a minute. Yes, sir.
What's the difference between accelerated and tachycardia?
Not a thing. You could call that accelerated. Yep.
So we would get the points if we said it was accelerated or junctional tachycardia.
Junctional tachycardia equals accelerated tachycardia. They're the same thing. Okay. All right.
Would accelerated be like above 100?
Nope, above 60. Because remember, we're going with the inherent pacing rate of the site. The pacing range for the junction is 40 to 60. 61 and above would be accelerated junctional tachycardia, or I'm sorry, accelerated junctional rhythm or junctional tachycardia. Anything 59 or less would be junctional bradycardia. There's no idioventricular junctional rhythm or anything like that.
Because I thought like it cut off from accelerated to tachycardia at like 100.
You may see different definitions in different textbooks, but for most of medicine, we just still call it a junctional tachycardia or an accelerated. Same. Okay. Anybody else?
So
Is
it's,
yeah.
junctional tachycardia or junctional bradycardia?
Say it again now.
You said it's only junctional bradycardia and junctional tachycardia.
So anything faster than 60 is junctional tachycardia or accelerated junctional rhythm. Anything less than 40, less than 40 is junctional bradycardia. There's no other name for that rhythm.
Okay, I thought you said 59
What if we call it junctional rhythm?
for junctional bradycardia.
I did. I was wrong.
Okay.
So it's 40 to 60. So it's anything less than 40. And please, I assure you, I am as tired as you are. And finals week is as stressful for your faculty as it is for you. When I say something goofy like that, please correct me because I don't want you to be confused. All right? Anybody else?
So it's junctional rhythm is junctional bradycardia, right?
Yeah. Anything less than 40 is junctional bradycardia. 40 to 60 is junctional rhythm. Anything greater than 60 is junctional tachycardia or accelerated junctional rhythm. All right. Your rhythm is regular to irregular, depends on AV conduction rate. Atrial rate is 250 to 400 beats a minute. Ventricular rate varies with the number of impulses conducted through the AV node, but will always be less than the atrial rate. P waves are sawtooth deflections or big F waves affecting the baseline. Can't get a PR interval, and your QRS is normal. What is that rhythm? Atrial flutter. Atrial flutter. Very good. Very good. What is that rhythm? That's perfect. That's exactly what that is. Normal sinus rhythm with a first degree block. Good, good, good. What's this rhythm? What is it, Sydney? You know, I can tell. Anybody?
Accelerated junction.
Mm-mm. Can't be accelerated junctional. Nope.
Junctional with PJC.
Nope.
Is it a junctional?
No.
Idioventricular, accelerated idioventricular.
No.
It doesn't have like,
It's too narrow to be idioventricular. Catherine?
I don't know what it is. I know it's not. It's irregular.
Do you see P waves?
I don't, so it's like AFib.
Say it again.
Is it AFib?
It is AFib. Yeah. Yeah, it's AFib. Okay. No P waves and really, really irregular. Now, here's the thing. You could potentially have a junctional rhythm, but it's almost always going to be regular unless we have a PJC or maybe a PAC or a PVC that's inserted in there. But it won't be kind of like an accordion playing back and forth and all over the place like you see up here with this one. It'll be regular, 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 early, regular, 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 early, and moving along that way. So this is a fib. Anybody not see why this was a fib? Sydney, did you have the right answer?
No.
Oh. All right. Next one. You're going to love this one.
It's the same thing.
I don't know. You tell me. It is a junctional rhythm. Why is it junctional rhythm and not a fib? It is regular. Yeah, it's regular. Remember, AFib is grossly irregular unless what? When can AFib be kind of regular? When it's tachycardic. You're exactly right. Exactly right. Rhythm is irregular. Rate is 60 beats a minute. It can go up to 100 beats a minute. P waves vary in size, shape across the rhythm strip. PR interval is 0.08 to 0.12. And your QRS complex is 0.04 to 0.08, which makes it regular or normal. What's this rhythm? Wandering atrial pacemaker. And wandering atrial pacemaker, Catherine, is what? What's the physiology behind it? What's happening in the heart?
There's multiple different pacemaking sites in the
Perfect. Perfect. What's that rhythm?
Yeah, it's the NSR with PACs.
Said what? NSR with what? Okay. You have two options here for this particular answer. I've called it NSR with PJCs. However, if you were to identify that as a PACs, I would give that to you as well. Why? Because whatever is going on is embedded in our T wave. So we cannot conclusively say is this a PAC or a PJC, but it's definitely premature. Yes.
So what makes you say that that's a PJC?
Because you can't tell me that it's not a PJC or a PAC because we can't identify the P wave. Now, again, if you wanted to get extra points, you could say complex 3 and complex 7 are the premature beats. All right. What is that? Oh, what's the difference between sinus arrest and sinus block? Yeah. So this is definitely sinus arrest. It's not sinus block. Okay. So I put that up there to remind me to ask you the question between the two of them. Okay. Very good.
On the exam, would we just put like sinus arrest?
Say it again.
Would we just put sinus arrest?
Then on this one, you just would identify this one as sinus arrest. If there's only one skipped QRS, then it's sinus block. Okay?
So we wouldn't have to say like it's the underlying rhythm.
No, there's no underlying rhythm for this. It's just simply sinus arrest or sinus block. Okay? What's this rhythm? Yes.
Can you have NSR with the junctional with the same beat?
Yeah. Yep, you sure can. Name that rhythm. Why is it second degree type 1? Yeah, look at your PR interval here. Okay, it starts out there, it gets longer here, it gets even longer here, and now it gets even longer, and then poof, we have no QRS. If we were to run this on out, we would probably see that the pattern is picking up and repeating with what we have over in here. Good job. Okay, here's a tough one. Kind of like the junctional rhythm we had a while ago or the AFib one we had a while ago. All right. That's VTAC. If I put up there is no pulse with this, what is this rhythm? That's right. Very good. Yeah. Rhythm is regular. Rated 60 to 100 beats a minute. PUA's normal size, shape, and direction. They're positive in lead 2. PR intervals normal, 0.12 to 0.20. QRS complex is normal. Ladies and gentlemen, what is that? That is normal sinus rhythm. That brings us to the end of